Hello, hello. Okay, perfect. Okay, the live stream seems to be working just fine. With excellent connection. Yay. Okay, so we're gonna start. Okay, perfect. Okay. Okay, so let's get started. So, yeah, we have got into these two systems, free systems, Meow and Phone. We still have two other systems, and then we have four VIP systems that we are gonna get into as well, hopefully. So let's get started. Okay. So we have finished this write up. We have read this Wikipedia, and we have learned about FTP and its command line. Beautiful. Let's open this new tab real quick. So now we're gonna allow the write up to show. There we go. So this called Dancing Machine Lab by 19. Great. So the introduction, there are multiple ways to transfer a file between two hosts computer on the same network. So we're gonna learn about SMB. Okay, so we're gonna just connect real quick to the VPN. Let's just check if we could just use the old one. Clear the screen, go to downloads, ls, and then we're gonna just take this file, copy it, and sudo into OpenVPN. Do this. Just gonna launch it real quick with syntax, and then now it doesn't look like that. Okay. So we are indeed connected to the network. Also connected to this machine weirdly, so we're just gonna exit real quick. Clear and exit from this terminal as a whole and leave it for the VPN connection. And open new terminal. Move it over here. And there we go, we have a new terminal that we could use. With the VPN, we are indeed connected to the server. This is our IP. So it's just gonna spawn the machine. Beautiful. And here it is respawning. Beautiful. So the introduction. There are multiple ways to transfer a file between two host computers on the same network. One of these protocols is studied in this example, and that is SMB server message block. This communication protocol provides shared access to files, printers, and serial ports between endpoints on a network. We mostly see SMB services running on Windows machines. So what we need to know about is that SMB is only found in Windows and cannot be found in Linux, okay? Just gonna make a new page in our notes in Notion. Then we're gonna call it so what did I call that last one? So I guess machine. Then just type in the name. That's it. This is the third machine. Yeah. Third or the fourth? That's the third. Okay. You just forgot an N. Beautiful. Okay. So we're gonna add our first heading. which we're gonna study about our recon. So we're gonna do a recon about this machine, and then we're gonna learn about SMB. It's gonna go to heading 3, then type SMB. We're gonna need a toggle list. We're gonna say definition. I just need to put that I guess, right? Yeah. This is directory dictionary. Okay. So SMB is bullet list. SMB is a Windows operating protocol that is not used in Linux systems. That's the most important thing. So this communication protocol provides shared access to files. So it provides shared access to files, printers, and serial ports between endpoints on a network. Okay, beautiful. We could add like printers, shared files between printers. Printers, yes. And serial ports. Serial ports, okay. On a network. This is the definition of SMB. So yeah, it's only running on Windows. So during the scan, okay, so we need to scan first the machine. It's gonna be here response. We're gonna just copy the IP address, access our terminal, ping it to see if we are connected to it. Yes, indeed. So we're gonna run our traditional nmap scan real quick, and then wait for nmap to scan all the ports available on this IP address. It's gonna take a little while because our connection is not ideal. It's pretty slow, like 3 seconds to reach one package. Okay, so oh my god, that's taking a huge while, like 15%. Okay, that's gonna be problematic. So let's just answer some questions in here. What does the third letter acronym SMB stand for? Okay, what does SMB stand for? Server message block. Okay, so let's just copy this. Okay, and submit the answer. Just add this to our notes real quick. And there we go, server message block added. Okay, so what does the third letter acronyms SMB stand for? Okay, so we're gonna need an acronym for it. So we're just gonna complete reading and then we're gonna find the answer. How much is left? 22%. This is pretty slow actually. Let's remove this version parameter. Okay, it's way fast right now. Okay, so we have this was open 135, 139 at BIOS SSN, and 445, which is Microsoft DS. So our question is which ports SSMB opens at? So because we're not going to use the guide always, most of the time we're going to use AI rather than Google and ask it what is the standard port for SMB Windows protocol. I'm gonna run that prompt and then it is 139. So indeed, so this part is the thing that we are gonna go and get the version of. So I'm gonna ask the AI, how could I specify one part on my nmap scan? I'm gonna enter that real quick because we will not then read the manual. It's way better to just ask AI. We're just gonna input nmap dash b, and then that will specify the port that we want, which is this port 139 of this IP address. So we're just gonna copy that and paste it. And okay, so it's gonna need to add another parameter, which is the version one. It's gonna take a little while, but it's gonna be way faster than scanning all the available ports. Okay, beautiful. So it is open. It is NetBIOS SSN, Microsoft Windows NetBIOS SSN. So I guess that is the second acronym of SSMB or SMB. Yeah, correct. Okay, so let's go and paste this. I hope it works. Oh, we have already answered this. Okay. Okay, so what portals SMP use to operate at? Okay, we just saw that it made our scan into. No, it doesn't. Okay, so we have multiple ports in here. We're gonna try each one of them. Let's try 135. Submit. No, still not the answer. What about 445? Okay, so this is the answer. Interesting. So AI has prompted us that the standard port is not. Oh my god. It is this port 445. And what did he say about this? Okay, historically, older version of SMB was used. Ah, okay. So this is the older version of SMB. Okay, beautiful. Just add this to our notes real quick. This is the definition. It's done. I'm gonna ask this question: which pores SMB uses? Then we're gonna toggle this, add our bullet list. The modern um, versions, for example, of this protocol uses the 445 words on the network. That's enough. The older versions, of the protocol uses the base port with 139. Okay, and yeah, which is Microsoft Windows NetBIOS SSN, right? Yeah, NetBIOS session service over TCP. Okay, this is something that do something with the BIOS, I guess. You can do this together. So this communication protocol provides shared access to files. I don't guess it uses anything related to BIOS. Just, shared access to files between printers and serial ports in the network. Okay. So during the scan that we have just made, we will typically see port 445 TCP open on the target. It is reserved for the SMB protocol. Okay, so it is the standard port for the modern systems. Okay, so usually SMB runs at the application or presentation layers of the OSI model pictured below. Due to this, it relies. So there is a model here. Okay, so this is the OSI model. So I don't understand actually what is OSI model. So we're gonna ask AI real quick. What is the OSI model? And it's gonna input this. Then we're gonna have this prompt. The OSI model stands for the Open System Interconnection Model. It is a conceptual framework used to describe how network communications work by dividing the complex process of communication between two end systems into seven distinct SQL layers. Okay, so this model is a conceptual framework. So it is a framework actually. And what it does, it just describes to us how the network communicates and work. It's just a scheme that simplifies the network that we use to in daily usage. So it divides the complex process of communication. So rather than, the computer does everything for us and not understanding anything, we could actually try to divide each step that the computer does and actually make it into little small steps of the communication that the network has to do. So between two end systems into seven distinct. So between me as client and server, we're going to divide this connection into seven distinct sequential layers. So we're going to have seven layers. So the network goes into seven layers before my connection reaches the server. Okay. So the main purpose of the ASI model is to provide a universal standard so that different hardware and software products from various vendors can communicate with each other reliably. Okay. Okay, beautiful. I'm just gonna ask this. So this is a B server. Just gonna add another heading. Heading 3, I guess. I'm gonna call it the OSI model. We're gonna need to learn about this model because it seems to be pretty interesting. And why not? I'm gonna add to directory dictionary. Okay, beautiful. Okay, so we were at this tab. So we're just gonna copy and paste this. Okay, so this explains that was I will pretty good. I'm gonna make a toggle list and call it definition. And then we could just input this. Beautiful. Okay, this is gonna be here. Okay, hold on a second. Okay, I'm gonna copy this real quick. Oh my god, no. Copy it, then delete. Okay. Okay, beautiful. And a bullet list. And there we go. So let's read this again so that we could simplify this even further. The OSI model stands for the Open System Interconnection. So it is an interconnection, which means it is an internal connection. So let's simplify this. Open System internal connection. So this is way readable than interconnection model. So this is a model, it is a scheme. Okay, it is a conceptual, it is just a concept framework. So we just make a concept of a framework, which means a conceptual framework used to describe how network communications work by dividing the complex process. So to understand how our connection goes from the client to the server, it divides to actually into layers, to multiple layers. So this is the scheme. It divides the connection to multiple layers. Okay, between two end systems. So my end as client and their end as server into seven distinct sequential layers. So each layer is different, which means it's sequential. So each layer follows the other as a sequence, like this. Then we reaches, the other end of the connection, interconnection, which is the internal connection. Beautiful. So the definition is done. Okay, beautiful. Okay. So yeah. So I have a trick. We could actually take this could take this scheme, or we could just Google it and see if there is a better scheme. Okay, see the images. Okay, application layer, presentation layer. Okay, so this one is pretty enough. So we're gonna download this. Save image as. Okay, OSI model. So after we have saved this, we could input in our definition toggle image, and we could upload the image for our computer. Open, there we go. So this is the OSI model. We have the application, network processor application, we have the presentation, we have the session, we have the transport, we have the network layer, we have the data link layer, and then we have the physical layer. So let's start with the physical from the very bottom. So the physical is media or signal and binary transmissions. So this is the bits that the computers inside, which is binary. If you're not familiar with binary, the binary is actually just a sequence of zero ones that computer understands. It is written like this. So yeah, it's pretty neat. Okay, and then above that sequence to the physical layer, there is the data link layer, which uses the MAC address. Oh, okay. So if you are familiar with the MAC address, it is the identifier of your hardware on the network. And you could change that by, there is a Linux command, and you could as well change it on Windows, which is change MAC or MAC change. I don't remember actually, but you could change it from the software, which is, a software identifier of your hardware. So this is the MAC address. Okay, you could actually spoof ethically the MAC address. So yeah, so that's a link. Okay, and LLC. I'm not familiar with this, but if you understood MAC, then I guess they are equivalents. We're just gonna skip that. And then we have the packets layer, which is the network layer. And this is the path determination, the IP logical address. And so here, where the IP address gets to work. So actually to get to the destination, which is the server, we need to know the IP address. Okay. So, okay, interesting. And then we have the segments, and these segments transport our physical and data link network into segments. And this an end-to-end connections. Okay. And then we have the session layer, inter-host communication, and then presentation data representation. So this gets compressed, I guess, transported, and then decompressed, and then presented, decompressed into a session. Okay, and then okay, here it gets decrypted if it was encrypted at the beginning. Okay, and it gets read by the application and processed. So I guess this is how the OSI model works. Pretty obvious, I guess. Let's just toggle this. Let's get back to the guide and read. Okay. So during scanning, we'll typically see this port to search for SMB. Okay, so SMB runs at the application or presentation layers. So if we got back, so he works at application and presentation. So SMB lives in this area. It doesn't exist in this session or transport or network or data link or physical layers. Only in these two above layers that exists. Okay, this is good information to know. So we're gonna go to SMB definition, and we're gonna go and say SMB runs on the application layer and the presentation layer. Okay, so just to not repeat the same thing, just gonna go and say and between these two terms and input the adjective, which is layer. Okay, beautiful. So this is the dictionary. Okay, beautiful. So SMB runs at the application or presentation layers of the SI model pictured below. Due to this, it relies on lower level protocols for transport. The transport layer protocol that Microsoft SMB protocol is most often used with is in NetBIOS over TCP/IP. Okay, this is why during scans we will most likely see both protocols with open ports. So mostly, okay, hold on. Okay, so we're back. So right now we're just gonna go and complete the studying. Okay, beautiful. So during the scan, we'll typically, okay, so mostly SMB is runs with um the NetBIOS service. Okay, over TCP and IP protocol. This is a protocol that is very obvious. Okay, what we use to the daily usage. Okay, over TCP and IP over TCP and IP protocol. Okay, beautiful. So this is why during scans we will mostly likely see both protocols with open ports running on the target. We will see this during the enumeration phase of the write-up. Okay, so yes, we did see the both protocols. Beautiful. If you would like to learn more about the SI model and other basic networking concepts, check out the Introduction to Networking module on HTTP Academy. So we're just gonna check this. Actually, we're gonna need to learn about this networking concepts because we are absolute beginners. Okay. Okay, beautiful. Okay, okay. So this is the Academy section here. Could unlock it for 10 of these things. Okay, then we could start it. Okay, thankful we have those. So networking overview. A network enables two computers to communicate with each other. Okay, so this is the network. Okay, we're gonna learn about network and the academy. Beautiful. So this is SI model, which is related to the network. So we're gonna go and so the SI model, does it fit in here? In Recon, it is more of a network kind of thing. So we're just gonna copy this and move it to the network section that it should be at. So we're gonna go to Hack the Box Academy, very easy machines. So actually it doesn't make any sense to call this very easy machines. It should be called networking. So introduction, I'm gonna just call this introduction to networking. Okay, beautiful. Just make a little shortcut into this, like intro into networking, way cooler. Okay, so we're gonna make our first heading. Okay, beautiful. So let's complete. So we have just written this into networking. Okay, so we're gonna make our first heading and we're gonna call it definitions. Definition. Okay. Definitions. Okay, okay. So we're gonna make our first bot list. So a network enables two computers to communicate with each other. So what is a network actually? So it is more of a tool or yeah, more of a tool or more of a connection. So network is a more of a connection between two endpoints. Okay, there is a wide array of topologies, mesh, tree, and star. So what do we mean by topologies? Okay, let's ask AI about this real quick. Okay, what do we mean? What do we mean about topologies? Topologies and this context. and then select run. We're gonna have this prompt. Okay, so in the context of computer networking, topology refers to the physical logical arrangements of the various elements, nodes, links, or devices. Give me a second, just doing a little configuration. Okay, actually that doesn't make any sense. I want to do it in my main device. Okay, so we're gonna full screen. Okay, so topology in this context of computer networking refers to the physical or logical arrangement of the various elements, nodes, links, or devices of a communication network. Okay, I don't understand actually. So it essentially describes how the device and a network are interconnected. Ah, okay. So this is the essential of it. It gives us a description of how the devices are connected. And this is the meaning of topology. So the terms you are mentioning, mesh tree and star, are examples of physical topologies, which describe the actual physical layouts of the cable and devices. It's a breakdown of what specific topologies mean. Physical topologies layouts. Physical topologies describe how the cables are actually run and connected. Okay, so this is the layout or the physical one. Okay, so we have the first physical topology, which is the star topology. And it describes that every device or node. Okay, that's pretty neat. What does a node mean? It means a device actually, right? Okay, that's interesting. I'm gonna make another tab of AI real quick so that we could make multiple questions. Okay, so we're gonna go like this, delete that, and press enter. Okay, so we're gonna have a new chat. We're gonna choose Gemini Lite because it's gonna be way faster. Then what does a node means in IT? And select run. How do you understand what a node means? So in IT, a node refers to any physical device or point that can send, receive, or forward data within a network. So a node is actually any physical device. Okay, interesting. So here in definitions, we're gonna have here we're gonna have a toggle list. We're gonna call this terms. So inside of terms, we're gonna have these definitions. So for node is any device on the network that could send, receive information. So over the network, okay? So this node exists in the network, right? And it is a physical device, any physical. So just me. That is not a software, it's more of a hardware kind of thing. Okay, I've written that wrong. Physical. Okay, beautiful. Okay, that can send, receive, or forward data within the network. So forwarding data as well. Or forward. Forward. Oh, what's wrong there? Forward. Oh, yeah, English. Okay. Okay, beautiful. So we have learned what a node is, its general definition. So let's complete reading this. So this broad definition encompasses a wide range of devices, from individual computers and servers to switches, routers, smartphones, and even Internet of Things. Internet of Things, we mean by that maybe a smart device on your house, or maybe that device that controls the lights. If you would like walk in, the light just turns on automatically, or the device that controls the temperature in your room. So, or maybe the fridge, maybe it is smart, or maybe, okay, so these called Internet of Things. Okay, and they are most using Linux as operating system because it is light. And yeah, that's it. Okay, so essentially, any component that connects to a network and facilitates communication can be considered a node. Oh my god, this is pretty good definition. So we're just gonna add this real quick. So in other words, any component that connects to a network and facilitates communication can be considered selectively a node. Okay, so nodes play a crucial role in the functioning of networks by acting as connection between points for data transmission, process recognition, packet switching, and network distribution. They are programmed to identify, process, and transmit data to other nodes, enabling the seamless flow of information across the network. Okay, so the term node can also have more specific meanings on the context. Okay, so we all have heard about Node.js, so we might get a definition about that. So in data structures, a node is fundamental unit that holds data and may contain links to other nodes, form a structure like linked lists, trees, or graphs. So this is more of a JavaScript thing rather than a network thing, this description. And in networking, that's what matches to us. Nodes can be categorized into two main types. In devices, these are devices that send receive data. Okay, we have learned about this. Intermediate nodes. Because we have sometimes intermediate nodes or distribution points. These devices like routers, switches, and modems. Okay, this is interesting. So we have two types. Okay, we're just gonna add this. And we have two types of nodes. And then we're just gonna go and paste them. It's gonna get rid of this bottle list because it's gonna get automatically. Okay, you can delete these references because AI uses these references as links, as resources or references, and you could actually click on them and make sure if this information is legit or not, and actually look deeper into these resources. So there's no need if we keep them on Notion, because what we need is just definitions. Okay, so this is a definition of JavaScript that we don't need. Okay, I'm gonna decrease the sound because I'm hearing some kind of piano. It's pretty loud. Okay, here it's pretty comfy on my ears. Okay, so it's full screen. Sorry, full screen to this. Okay, beautiful. Okay, so we are learning about the star topology, which is a physical layout in the network. So, description. Every device or node in a network is connected to a single central connection point, which is a hub or switch. Pros, easy to install and manage. If one node or cable fails, only that single node is affected. The rest of the network remains optional. Cons, central device switch hop fails, the entire network goes down and causes more cable. Okay, so this is their star topology. Maybe we're gonna have a scheme about it that we could use. Yes. So this is a star topology scheme. So in the star topology, we have a central hub that connects more nodes or end devices into it. So if this device has failed, then these remains functioning and actually working. This only connection is going to get interrupted and it will fail. But in the case two, if this hub or central switch fails, then all of these connections between these devices are gonna fail and the whole network is gonna get down. Okay, beautiful. So we're gonna go and save this image. Just restore topology. Okay, I'm gonna go and save that. I'm gonna go to our Notion notes and upload it. Okay, so we are learning about not node, we are not learning about node. We are learning about this is gonna make a headache. Headache 3. We call it star topology. So what do we mean by star topology? So we're just gonna go and upload an image. I'm gonna select it from our VM. Then we're gonna open it. And here she is uploaded. Okay, beautiful. Okay, that sounds pretty great. So, yeah. So we will learn about this. Okay. Okay, so the description of it is this. So every device that's connected in a network is mainly connected by a switch or a central hub. Let's make a bullet list. So every device or node, let's keep it as node because we have learned what node means. A node is way better. Then it's connected a single central connection point, such as a hub or a switch. Okay, beautiful. So we know that right now. Okay, and pros of it, maybe just gonna add these two details into it because why not? If the central hub. Okay, wait, central hub fails. Then the whole network goes down. Oh, network goes down. But if one node fails, then only one connection gets interrupted. Okay, maybe double error, I guess. Yep, interrupted, and the network still functions. Okay, beautiful. So the mesh topology, so this is another topology. Every device or node is connected directly to every other device in the network. Okay, okay, that's interesting. I'm just gonna find a scheme about it and we'll learn about it real quick. So this is the mesh topology. So in this case, we're gonna take one of these schemes. We're gonna take the simplest one, because this one. So in a mesh topology, yeah, we don't have a switch or a hub. We just have multiple computers connected with each other using Ethernet, for example. This guy using this Ethernet, each other Ethernet cable, Ethernet cable. There is no hub that simplifies the network. So it looks like a net rather than a four-directional network. Okay, interesting. There's this other scheme. This way simpler, I guess. So we're gonna download it. So where is it? Open image, copy image. Save link. I don't know why we can't save this image. Okay, good. So we're gonna call it mesh um topology. I'm gonna hit save. Okay, then I'm gonna go to our Notion and upload it as image. And before that, we're gonna need to make a similar heading. Okay, I'm gonna call this mesh. Maybe this is a typo. Topology, yeah. So we're gonna need to add over here. Okay. Upload the image. So we're gonna go to image, upload file, and then we're gonna select mesh topology, open, and there we go. Then I'm gonna go to AI and copy the description, and then paste it into our notes for later revision, for example. Oh no. Okay, beautiful. We just need to know a little bit about networking. We should know a lot or get a certificate and waste money. No, that's stupid. If you want to understand, then this is the simplest way to do. And this is actually very obvious. Like, okay, like there's a central hub that we know about this. We have routers in our houses. We have access points in our houses. So we are actually familiarized with these type of networks. Or maybe you have made a special network between three computers and all of them are connected like a topology. So all of this is obvious. So yeah. So yeah. So the pros and the cons. It's actually very simple. Like we don't need to read that. So we're just gonna go and intercept these. We're gonna say if one device fails, if one device fails, then the whole network fails. Because, for example, this central device, if it fails, are not gonna have a connection to this, or this, or this, or this. If these endpoints don't have a connection, these four ones, then this and this we're not gonna have any connection between them. Okay, so this one's gonna fail to transfer this file. This one won't receive this file as well. So the whole network fails. Okay, so that's my guess. So let's read. So extremely fault tolerant and reliable because there are multiple paths for data to travel. Oh no, so that is wrong. Yeah, that's obvious. Because if this one fails, then we still have these connections over here. So I'm just gonna delete this. There is no pros and cons. The only cons is it is expensive to install. It's a little bit messy. Okay, so that's the full and the partial. Yeah, interesting. Then we have the tree topology. Just gonna add this up over here. Um, could actually make the same heading by just copying this one, pasting it in here. We're gonna call this tree. We capital T. Okay. Okay. So this is a hierarchical topology. So the description is this topology combines characteristics between the boss and star topologies. So this is a hybrid topology. So we're just gonna go and make a bold list. So the tree topology is a hybrid topology inspired from mesh and star topology. Okay, so we have repeated topology 3 times. Interesting. So you see. Oh no, it is a hybrid between the boss topology, but we haven't learned about the boss topology. Okay, let's check the scheme of it. And actually, because it's all obvious, just need to look at the scheme, that's all. Okay, so this is the bus topology. It is more of a line or a cable, one Ethernet cable. So imagine it as one Ethernet cable that has the ability to extend to these small cables. This is the bus topology. I have never actually seen such a topology. Maybe I did, maybe not, but it is pretty awkward. Okay, so let's continue. Okay, so it consists of groups of star configured workstations connected to a central linear bus cable. The backbone, it looks like an inverted tree. Okay, so it consists of groups of star configured workstations connected to a central linear bus cable. The backbone. So this big Ethernet cable is a backbone. And we're gonna see the same on the tree. Apologies, because it is inspired from the boss one, right? Oh no, it looks more like a tree. Okay, let's take one. This one is pretty simple. Okay, so we have the root and we have the leaves over here, like an extension of the root. So it's multiplied to 2, and then we have a 3 1. Okay, beautiful. Okay, I understand. It consists of a group of star configured workstations. So it consists of these star ones. So let's take a look at the star topology. So it consists more of these. Okay, let's make sense of this. Groups of star configured workstations connected to a central linear bus cable, the backbone. Okay, so this plays as the backbone. Okay, interesting. Uh-huh, connected to the central, the backbone. It looks like an inverted tree. Yeah, true. So the pros of this is that it is good for expanding large networks from a central root point. Okay, so as a third root, so it is pretty good to expand from the root. With the cons, if the main backbone cable fails, the entire segment of the network connected to that backbone fails. Okay, beautiful. So we're just gonna add a little notation into the mesh topology so that we keep the pattern of pros and cons. So the pros, very reliable, but very expensive to install. But with the tree topology, we're just gonna go and save this image as tree topology, topology. Okay, so there is no typo anymore. I'm gonna hit save. I'm gonna go to our Notion, paste the image. Okay, gonna hit upload file and select it. Okay, that's great. Oh my god, I'm very tired. I'm sick as well. But we could still do this. Oh my god, it is way big. A bit smaller would be just fine. Just like these other ones. Okay, makes sense. Does make sense. Okay. So it is a hyper topology inspired from the not the mesh but the bus topology. Okay, in the star topology, we're just gonna go and take this connected. This was the arc all connected to the backbone and looks like an inverted tree. So we know the looks of it. This is gonna be this one that we miss in our definition. And we're gonna add it here. And we're gonna just delete this space right over here. And we have a perfect uh, and simplified definition of the tree topology. I'm just gonna add the pros and cons. Um, so these are wonderfully explained. There's no need to actually edit them. And paste these, select them and put them here. Okay, good. So we're just gonna add the bus topology as well because we have learned about it. And we need to know what is the bus topology in order to understand the tree topology. It's gonna paste this, replace this one with the bus, and then get back to the bus topology, and then select this image, save it as the bus topology. Wonderful. Hit save. Okay. Then we're gonna go and we're gonna paste it in our Notion. Okay, I'm just gonna go and select image. Wonderful. We're gonna upload the file, tree topology, and then we're gonna just do it like this. Beautiful. And then we're gonna add a bullet list. Explain what is no, not this one. The post topology. What the fuck is wrong with me? Okay, hold on a second. Okay, that's problematic. Let's change the image, replace. Yeah. So I meant the post topology. Okay, great. So let's make a bullet list and get the definition of it. So what is the post topology? Hit enter. Okay. Oh my god, that's very, very, very too much actually. All this network topologies, okay. So central cable, we have a backbone, and okay, we have terminators, two ends of the central cable must have terminators attached. These terminators absorb the signal when it reaches the end of the cable. Okay, and we have a shared medium. All devices share the same single communication medium. So all nodes share the same backbone. Okay. And the backbone is a central cable at this case. So it is a very old topology. It actually consists of the let's here. Actually consists of a backbone or a central cable. Uh, okay, under parentheses, it's called, hold on a second, it's called backbone. Okay, attached to uh, attached at the ends with two terminators. They're mini terminators to absorb the signal. Okay, so what does this mean? Just make this a bit bigger. So the signal starts from this computer, for example, and then gets transmitted from both directions, this direction, this direction. So there is a terminator in here. It absorbs the signal. It doesn't get further into the air and space because that's impossible. Then it goes to this computer, gets reached here, and here, and here, and here. Then it gets absorbed in here as well. So right now we're just gonna go and check about the costs and the pros and cons. So it is very easy to install. It requires this amount of cabling compared to the other types like star or mesh. So it is very to install compared to the other topologies. Okay, so just make another bullet list. So very easy to install compared to other topologies. Okay, we have a typo in here. Okay, typologies. No, we don't have a typo. We don't have a typo, everybody. It's correct. Topologies. Okay. And it is very costly. It is inexpensive, but it is very poor if the main backbone cable breaks. Okay. So this is the very easy to install and inexpensive. Inexpensive. Compared to other topologies, just gonna add this to the dictionary. I don't get that error anymore. And we're gonna go and hit enter. And Then we're gonna say what is the cons. So the cons, if the backbone breaks, then the whole network fails. Okay, that's the stupidity of or the cons of post topology. Okay, good to know. Guess we could go and read more about this. Page one. So this is how we should learn the basics or the fundamentals of networking. Because without networking, just forget about hacking. So it is a very essential and basic fundamental that you should absorb before you even think about getting into this. Okay, so and we have the mediums like Ethernet, fiber, coax, and wireless. So the mediums of transfer like Ethernet and etc. Pretty obvious. And protocols like TCP/IP, UDP, and IPX. So actually, I want to learn about TCP, UDP, and IPX, about network protocols. Okay. So after we have learned about mesh topology, star topology, okay, I'm gonna make a toggle list about these guys. I'm gonna go and copy them, then delete. Okay, then we're gonna go and make a toggle heading 3, I guess. Then I'm gonna call this network topologies. Topologies is, in other words, schemes, of how the networks are configured between nodes and central hubs, etc. And then we have all the info that we need just over here. And then we could close this and revise it for later. So right now we're gonna make our third heading, and we're gonna learn about internet protocols. Okay, internet protocol, and it's gonna be TCP/IP slash IP. Okay, we're gonna add this to the dictionary. Okay, so just gonna type here TCP/IP. And we're gonna type this. We're gonna have a scheme. So we have this scheme, pretty classical, I guess. So this is how the TCP/IP model is made of. This is pretty similar to the OSI model, okay? Because we have the transport, etc. Let's see if we have a better one. Okay, this one is way better. So network, this is the first layer. We have the Ethernet or the Wi-Fi, which is wireless local area network. And then we have the internet, which is the IP address. So the SI model just goes pretty much in detail, but it is way similar to the TCP/IP model. Then we have the transport, TCP or UDP. Then we have the application which uses HTTPS, ALS, or DNS, etc. This one is way simpler than it should be. Okay. So we have these layers, same layers. Okay, great to know. So we're gonna have this one because I just like it. I'm gonna call this TCP IP protocol. So we're gonna go to our Notion. Then we're gonna paste this right away. Oh no, sorry. We're gonna need the image. Select it, upload file. Then we're gonna go and select TCP IP. There we go. Okay, we're gonna ask the AI what is TCP IP protocol. Okay, so we have this prompt. So it says that TCP/IP protocol suite, often just called TCP/IP, is the fundamental set of communication protocols used for the internet in the most modern computer networks. It dictates how data should be packaged, addressed, transmitted, routed, and received between different devices. Okay, so this protocol actually lays the ground layer of how these information should be transmitted between my endpoint and another, for example. So the names, so the name comes from its two most important protocol, TCP, which is Transmission Control Protocol, and IP, Internet Protocol. Okay, we're gonna make this a little bit simpler. So, so it dictates how. So it is a dictator, like Hitler, ethically. I don't want to get spammed about this. But yeah, it dictates how data should be packaged, etc. Interesting. Okay. So the name comes from two important protocols, TCP and IP. Okay, so TCP stands for this and IP stands for this, key internet protocol. Okay, we're just gonna copy this. Okay. Pretty sick this day. It's pretty cold, actually. It's the winter, so it's normal to be sick. Okay, so we're gonna make our first bottle list. I'm gonna call this TCP. It stands for this protocol. I'm gonna close the parentheses, which means transmission control protocol, and then we have the IP, which stands for internet protocol. Okay. Okay, so this protocol actually dictates this transmission in the network. So we're just gonna paste this as well. So generally it just gives, this is a pretty strong word, how data or lays the ground rules of how data should be packaged, addressed, transmitted, routed, and received between different devices. This is way better than dictate. Okay. Okay, great. So the two core protocols, we have IP, internet protocol, the addressing and routing layer. Okay, so the IP takes these two layers, the addressing and routing. So we're just gonna go to our scheme, and then, oh my god, we don't have this. We have transport, internet, and access. Internet. Okay, interesting. It's a bit difficult to understand. So it's responsible for addressing and routing data packets across network boundaries. Okay. So function ensures that data travels from the source device to the destination device, even it has to hop through many different routers and networks along the way. Okay, so the IP is actually responsible for addressing maybe Google rather than Bing or DuckDuckGo. Okay, it just gives us this address and we stick to it. For example, in the internet, and we're gonna hop over multiple backbones on the internet until it nodes until we reach the destination IP address. This is actually what this protocol does. So it uses IP addresses to actually specify the address of the node that we are trying to send our packages to. And there is the version 4th, which is the one that's pretty easy. Again, there is the 6th version, which we don't use at the moment. Like some use it, but it's not actually mandatory. So as the logical addresses for source and destination. Okay, so he says here best ever IP provides an reliable connectionless delivery service. It tries its best to get the packet there, but it doesn't guarantee delivery, order, or error checking. So for example, we might have an IP address of a device, but for example, we have a broken internet. For example, our switch is not transmitting data as it should be. So even we have the IP address and we have this protocol configured, sometimes those packets are not going to be sent. So yeah, just to know that it's not like magic. It's gonna work because we have the IP address. No, we should have a functional network. Okay. So TCP transmission control protocol, the reliability layer. So the transmission control protocol sits on top of IP and provides the reliable connection-oriented services that applications need. So the function, it guarantees that data arrives at the destination completely in the correct order and without errors. Okay. So this one is more reliable. Okay. And it sits on top of the IP address. That's why we write it on top of it. Okay. So the function guarantees that data arrived to its destination completely. So connection setups, it established connection using a three-way handshake. So sync and send. So this send and send is like hello there to the server, and the server responds with send, and then you send, and then he sends the server responses with send ag. It's like hello there, are you there? For example. And then I say to him, yeah, I am here. So we could translate this to send, hey, are you there? It's like, hey, just hey. And then the server says, hey, I'm here. Hey, I'm here. Are you there? Then I see, yeah, I'm here. So this is the three-way handshake. And we use this three-way handshake to connect to the Wi-Fi, for example. So as you input the Wi-Fi password, okay, it transforms to this encrypted three-way handshake. And then, for example, somebody could actually sniff this three-way handshake and try to brute force it and get the password, reverse engineer it, and actually access your Wi-Fi just from this protocol. That is still used until today. Okay. So before data transfer begins, so reliability. It numbers the data segments, checks for missing segments, transmits whole lost segments, and reassembles the segments. in the correct order at the destination. Okay, beautiful. So this is the TCP IP model for layers, while the OSI model has 7 layers, though the OSI model is different than TCP IP because TCP IP has only 4 layers. So TCP IP model simplifies this into 4 conceptual layers that map more directly to the actual protocol in use. So, my God, I just remember the OSI model. We didn't actually copy it, did we? Okay, let's check that out. And go to our third machine. Yeah, yeah, we didn't copy it and paste it into here. That's problematic. So we're gonna go to the version history. We have only one version. Oh, that's problematic. Only have one version. Okay. Okay, that's okay. We have just lost our OSI model. No, help. Okay, it's fine. It's fine. It's not the end of the world, is it? We do still have this live stream, you know, which is a plus. I could get back to the live stream and actually learn more about SI model. Or, you know, that's why the stream exists. Okay, beautiful. So let's complete. Okay, so it has 4 layers. Okay, and etc. So we have the application. So we're gonna start from the network access layer. This is the first one. It uses data link or physical, and it deals with the physical transmission of data over the local network medium, for example, Ethernet or Wi-Fi. And then we have the internet layer, which is the network, which handles logical addressing and routing across network, IP, ISMP. Then we have the transport layer, which handles host-to-host communication, reliability, and segmentation. Okay, in this we use the CCP protocol, which uses the sync, ACK. Okay, the three-way handshake to actually set up the connection, and there it function. Okay, and then we have application layer, which provides network services to the user application like HTTP, HTTPS, for example, the website or the FTP server or the SMTP or the DNS server as well. Okay, beautiful. So we are going to not copy all of this for sure. So IP, it uses this to address destination. Okay. Okay. So TCP is built on top of IP protocol. Okay. And it lays us the ground rules. Okay. And the IP protocol, it uses IP addresses to actually transmit the information to the destination. Okay, it actually ensures the data transfer of the source files to the destination, even it has on top of very many different. Okay, this is a very good definition. And so IP ensures that data transfers from source device, so from one node to the destination node. Oh my god, what did I do? Okay, the destination node, even if it has to hop through many different routers and networks along the way. And in that manner, it uses IP addresses as logical addresses for source and destination. Beautiful. Okay. Uh, Surely it tries its best, but it's not reliable and connectionless delivery service. Okay. What do you mean by connectionless service? I'm just gonna get into that right away. So we're just gonna hit it right, but it's not reliable and connectionless. Okay, do we have a typo in here? No, we don't. But it is not reliable in connectionless delivery service under these two penalties. Let's say um if the network if the network was not correctly configured, thus uh thus no no for example a failing hub or strong unit and network. Okay, beautiful. Beautiful. Yes, so this makes actually sense. So let's get deeper. So it tries its best to get the packets there, but it doesn't guarantee delivery, order, or error checking. And here we have the TCP, Transmission Control Protocol, the reliability layer. So what we need to know about TCP is that it establishes this three-way handshake before transmitting data. Okay, we're gonna go here to TCP. This is built on IP. It plays to around rules of networking, and it establishes. Okay, okay, I have an idea. Why not? We should use this. This is gonna be way more readable. So IP address does run for one nodes, even on the way. It uses IP addresses, so rather than using ends like this, we just use another bullet list, okay, as logical source, but we could use another bullet list. Exactly. Hold on a second. Let's just put it in here, then in here. Okay, fine. Okay. Oh, this is perfect. Add these guys to the dictionary. Okay, beautiful. Okay. So it guarantees. So why does it guarantee the data that is transferred? Because we do the three-way handshake before even we start transferring the data or the information. Okay. That's why it says more reliable than only IP. Okay. We make sure that the server is on and online and reachable, then we start transferring data. Okay. So then he add up a little heading. I'm gonna call this conclusion. So IP IP protocol does not use um, safety mechanism. Okay, let's just correct this. Oh my god. Doesn't use it doesn't make sure, does not make sure that the destination is T. Okay, hold on a second. Is T on this destination. Okay, beautiful. Does not make sure that destination is reachable before transmitting data over the network. Here, unlike unlike the TCP protocol, which has a which performs hold on a second, which performs the three-way handshake. Okay, so this is the conclusion of this whole text over here. Okay, and this is actually the TCP/IP Internet Protocol. Okay, so I'm gonna take a little break. The stream is gonna continue. 15 minutes, 20 minutes like that. I'm gonna get back. Okay, so we're back and we have so much energy and we could get back to our studying soon. So we will last at this conclusion that we have made. Okay, great. So these protocols, TCP, UDP, PX, we have learned the TCP protocol. Now we have UDP and IPX. So let's get into it. Okay. So we have the UDP protocol. So we're gonna go to hackthebox academy. Intro into networking. Then we have learned about this protocol. Then we're gonna learn about another one. I'm gonna put here hidden 3, actually hidden 2. Hold on a second. What's happening? What is happening? Okay, hidden 2. I'm gonna input UDP protocol. Add this to the dictionary. Great. So let's start understanding this UDP protocol. We're gonna look for a scheme on the internet. UDP protocol. Okay. So this is the UDP protocol. What about this one? Okay. Interesting. Okay, so we have here user datagram protocol, UDP. UDP characteristics. Okay. It's more of a text rather than a scheme. What about this one? User datagram protocol. Okay. So we are the sender, we give a response. Okay, so the receiver gives a request. What? These are trashy schemes, my dog. It's like one of the trashiest. What about this one? So request data and we get data. That's it. Yeah. Hey, that's a weird protocol actually. Yes, we have this UTP header. Interesting. So UGP and APX are not as famous as TCP, not as usually used. So let's just ask the AI, what is the UGP protocol? Let's read a little bit about it. If we didn't find a scheme, it's all right. We could as well use the Wikipedia, UGP protocol. Okay, and then here it is use the datagram protocol. See if there is a, okay. So this is the structure. We have the data section, etc. Checksum. Okay. It's a little bit boring actually. It's not that fun as TCP. This is what AI said. ETP stands for Use Datagram Protocol. It is one of the two primary protocols at the transport layer of the TCP IP and OSI models, the other being TCP. UDP is often described as fire and forget or best effort protocol because, unlike TCP, it prioritizes speed and low latency over guaranteed delivery. Okay, interesting. So unlike TCP, it prioritizes. Okay, so there is no three-way handshake to ensure the data connection. No, it doesn't do that. Okay, so use UDP unlike TCP. It has this feature, which is speed. So these are the key characteristics of UDP. So connectionless. UDP does not establish a formal connection like the TCP three-way handshake. Before sending data, it simply sends the data out, known as datagram, to the destination IP and port. Okay, interesting. So it simply sends the data. That's all it does. Okay, interesting. So we're gonna add here a heading 3 for the definitions. Okay, add here to the dictionary. Okay, so unreliable. So it doesn't offer a guarantee of delivery. So the packets might be lost or duplicated or arrive out of order. And the protocol itself does not attempt to detect or correct these issues. That's why it's not that much used. So it does not guarantee. Interesting. So it is quite the opposite of TCP. Okay. Does not guarantee. Let's correct this. Okay, guarantee, datagrams, dictionary. Okay, let's just make this text a little bit more readable. Beautiful. I'll attempt to correct these issues. Okay, interesting. Datagrams, so no overhead, low latency. Okay, datagrams. The data unit for UDP is called user datagram. When is UDP used? UDP is the preferred protocol when speed is more critical than perfect accuracy. If a few lost data packets are acceptable in exchange for low latency, UDP is the choice. Common applications that use UDP include DNS, domain name system, streaming media, video, VIP, online gaming, real-time action games with UDP distinct frequency. Okay. SNMP, Simple Network Management Protocol, used for network monitoring. Okay, interesting. In summary, is HTTP fast, lightweight, and connectionless. Okay, I do get it. Okay, interesting. So we're just gonna copy this and I'm gonna make a toggle list, which applications uses UDP. Okay, and then we're gonna paste this, maybe for revision or who knows. Interesting information. I didn't know that before. Okay. We could as well get a scheme. This one seems not this one actually. Okay, this one seems to be way better than request and receive because you don't get anything out of it. So we're gonna save the image and check it as UDP. Yeah, for TCP as well, we need a scheme for TCP, the three-way handshake as well. Just gonna see that. We do have it. Oh yeah, we do. So here we have sync act to ensure the connection, and here we don't. Just straight away, if there is a server, okay, if there isn't, I'm gonna send it anyways. I'm gonna save this as well. Then I'm gonna save this as TCP. Okay, wonderful. So we're gonna go here, So TCP IP layers. Here we are talking about TCP. So we're gonna make the image over here. Image. Then we're gonna upload a file, choose TCP, then open it. And then lower that image a little bit, make it smaller. Okay, here's the IP, which contains of that. And here's the conclusion that we have made. Here's the UDP protocol. Okay, and we're gonna need an image of it. Scheme, how does it function? Okay, not this one. UDP, yes, this one. Okay, so this one is the UDP. Just bare data without any connection checking measures. Okay. Then I have this one we just did. Then we have TCP over versus UDP. I'm gonna make a third heading. I'm gonna call this TCP versus UDP. And then I'm gonna upload this image. And then I'm gonna take this one. Yes. It is pretty obvious. So TCP has the three-way handshake, but UDP does not have it, which makes UDP faster and TCP slower. Okay, just gonna need to make this like this, TCP, UDP, and here UDP, and here TCP. Beautiful. Okay, so it's complete. Okay, so when UDP is used, so we have learned about UDP. What's next? Just EPX. What are EPX? We need to learn about EPX. What is it? I never knew about it. So EPX is this. No, it isn't. This one is Chinese kind of thing. Let's type here pro to call. Yeah. This is a typo. So EPX protocol E, this is the scheme. So it uses proxy, uses the NS, and uses these. Interesting. So let's understand it together. What is EPX protocol and what is its compared to TCP and UDP? So the EPX protocol, Interwork Packet Exchange, is a network protocol that was primarily associated with novel netware environments, which were dominant in local area networks, okay, before the widespread adoption of TCP/IP. So this one is a older protocol. Okay. EPX is the network layer protocol within the EPX-SPX protocol suite, developed by Novell. So it has its own layers. It operates at level roughly equivalent to the network layer layer 3 of the OSI model, similar to IP. Function. Its primary job was to provide connectionless data packet exchange between network nodes, much like IP. It handles addressing interaction across novel networks. Addressing IPX used a different addressing scheme than the hierarchical IP addresses. IPX were typically 80-bit long. Okay, so this one is not used, so it's useless to actually know. Just more information that we don't need. So let's skip it. Okay. Okay, so let's read this. A network enables two computers to communicate with each other. There is a wide array of topologies, mesh tree star, mediums, like Ethernet fiber or coax, and wireless, and protocols like TCP, UDP that can be used to facilitate the network. It is important as security professionals to understand networking because when the network fails, the error may be silenced, causing us to miss something. Setting up a large flat network is not extremely difficult. It can be a reliable network, at least operationally. However, a flat network is like building a house on a land plot and considering it's secure because it has a lock on the door. By creating lots of similar networks and having them communicate, we can add defense layers. Pivoting around a network is not difficult, but doing it quickly and silently is tough and will slow attackers down. Back to the house scenario. Okay, let's understand this. So if you want to build a network, it's like building a house on a land. And after you did your building, you should put a door and lock it, right? By creating lots of smaller networks and having them communicate, we can add defense layers. Okay, pivoting around the network is not difficult, but doing it quickly and silently is tough and will slow attackers down. Back to the house, okay. So this is an interesting note. So back to the house scenario, let's walk through the following examples. So the first example, building smaller networks and putting access control lists around them is like putting a fence around the property borders. So if we're building these defense mechanisms, which are small networks, it's like putting access control lists around them. So around each smaller network, we have a access control that checks if you have the credentials, I guess. It's like putting a fence around the properties border that creates specific entry and exit points. Okay, okay. That's interesting. Interesting. So we're gonna use AI to actually generate a scheme. I'm excited to see which scheme we're gonna have out of it. So we're gonna use the banana. Where is it? Yeah, the banana one. So in order to create this, so create an scheme out of this. Let's see what I would make for this one. Okay, so it's gonna take a while, but in the meanwhile, we're gonna complete reading. Okay, it's like putting a fence around the property's border that creates specific entry and exit points. Yes, an attacker could jump over the fence, but this looks suspicious and is not common, allowing it to be quickly detected as malicious activity. Why is the printer network talking to the servers over HTTP? Okay, so example number 2, taking the time to map out and document each network's purpose is like placing lights around the property. Okay, making sure all activity can be seen. Why is the printer network talking to the internet at all? Okay, building number 3, so example number 3. Having bushes around windows is a deterrent to people attempting to open the window. Just like intrusion detection systems like Suricata or Snort are a deterrent to run network scans. Where did the port scan originate from the printer network? Okay, so he's asking about why a printer has access to internet and running on HTTP. So why did a port scan originate from the printer network? Okay, these examples may sound silly. It is common sense to block printers from doing all of the above. However, if the printer is on a flat 24 network, in case a DHCP address, it can be challenging to place these types of restrictions on them. Interesting. So here we have a story time. Pinterest's oversight. Okay. So most networks use a 24 subnet, so much so that many penetration testers will set this subnet mask to this, okay, 255, until 0, okay, without checking. The 24 network allows computers to talk to each other as long as the first three octets of an IP address are the same. So, okay. So setting the subnet mask to 25 divides the range in half. The computer will be able to talk to only the computers on its half. You have seen penetration tests reports where the assessor claims a domain control was offline when it was just a different network in reality. The network structure was something like this. Okay, interesting. So I'm gonna simplify this by AI. Could you please explain this better and with examples to facilitate the understand let's add the human understanding. Then I'm gonna paste this and run control. Okay, so that's the scheme of a flat network. That's AI generated. So segmented network adding defense layers and flat network. Okay, as the devices, single points of failure, more secure, segmented network. And this one is a flat network. Printer, servers, HP, okay. Firewall, routers, okay. Attacker detected one off the fence. Okay, that's funny. That is actually very funny. Okay. So if the network was correctly configured, it is way easier to detect malicious activity. Interesting. So yeah, the APX, no, not this one. Okay, let's get back. Okay, so this excepts highlights a very common real world scenario in network penetration testing that resolves around understanding subnet masks and network segmentation. Okay, so the core concept, what is a subnet mask? IP address like this one identifies where a device is. A subnet mask is like 24 mask, .NET mask, defines how big the local network subnet is. Okay, so here I guess there is 200 devices that could be connected. The subnet mask separates an IP address into two parts: network ID, the street name, for example, which devices can talk to each other directly without a router. Then we have the host ID, which is the host number, which is the unique ID of the device on that network. Okay, so the standard 24 network subnet is shorthanded for this IP address, or it's called IP mask or whatever. Who cares? So what this means, okay, it's the first three numbers, octets, of the IP address must be the same of two devices to be on the same local network and talk directly. So this one and this one on the same network, but this one and this one are not on the same network. Because here we have one, here we have two, right? We're on different networks and need a router gateway to communicate. So for this network, we need a router or a gateway. So here, in our case, the pen tester's mistake. Many testers assume every network is a simple 24.net because it's common. They might set their own IP to 24 without checking the target network actual mask. So the real scenario, a divided network with 25. So the network being tested in this example is not a standard 24.net mask. It is split into two smaller separate networks using a 25 mask. So understanding the 25 mask is shorthanded for this IP address. What it means, instead of allowing 254 hosts, like yes, as I said, 200, almost 200 for the normal subnet. This one is divided into two separate networks, each of them allowing only 126. So the network is split into subnet A, subnet B. Okay, so the devices within subnet A can talk directly to each other, and devices within subnet B can talk directly to each other. Devices in subnet A cannot talk directly to devices in subnet B. They must go through a router gateway. Okay, interesting. And in subnet A, we could actually talk to each other. Yeah. And devices with the subnet B can tell what they need. I cannot. So they are on different subnets. That's why. So this one, okay. And this one, okay. So they are on different subnets. That's why. That's why you cannot communicate from this device to that other. Okay. Okay, that's a little bit in detail. So we do understand. What does this mean? So the pen tester IP address cannot communicate with these guys over here because the .NET is different. So here it seems like they are on the same network, but no, it's a different .NET mask. That's why we can't. We should set a gateway first, then we could communicate. So the pen tester communicated with the client workstations and thought they did an excellent job because they managed to steal a workstation powered via M packets. However, due to a failure to understand the network, okay, so this attacker did an excellent job and managed to steal a workstation password. So this workstation, for example, via M packets, via a tool called M packets. However, due to a failure to understand the network, they never managed to get off the client network and reach more high-value targets, such as database servers. Interesting. So due to a failure to understand the network, they couldn't manage, they never managed to get off the client network and reach more high-value targets, like databases. Interesting. Hopefully, if this sounds confusing to you, which is, motherfucker, you can come back to this statement at the end of the module and understand it. Okay, so here we have basic information. Let us look at the following high-level diagram of how a work from home setup may work. So, okay, interesting. So we want to know this. Okay, so let's just copy this. Copy as text. So I want to make use of this that I could get back into later, which you make on for Notion, and then paste this and then let the AI do the work. Because that's a lot of info and I'm not willing to note each thing again. Let the AI do the hard work, right? Okay, so this one is my okay, so this is the prompt. Network segmentation, the subnet MAC trap. A critical networking concept. Okay, so this one is the heading we're gonna add into Notion. For us to understand this misconception of actually this mistake of being on a different subnet mask and not being capable to actually communicate with a network. It's cool to understand, I guess. So it is in this criteria. Yeah. We're gonna add a toggles heading, and then we're gonna paste this into segmentation, the subnet mask trap. And then we're gonna paste what AI has said. Okay, so we have the core concept, subnet mask defines scoops, etc. So we're gonna copy all of this. Then we're gonna paste it. Then we're gonna read it on Notion so that we could understand even more. So the core concept, subnet mask defines scope. Okay, so the subnet mask determines which part of an IP address identifies the network. Okay, like the street name versus the house number. So the network ID, okay, devices sharing the same network, as you can communicate directly. Host ID, the unique identifier on that network. Common versus actual machine. This one's the common one, and this one's the actual one, being divided into two separate networks. The real world example is, okay, just one of these. Beautiful. Segmentation. In this scenario, the network used a 25.NET mask on this IP range, effectively splitting it into two non-communicating segments, subnet A, subnet B. Okay, server gateway and domain controller, etc., etc. So penetration testing pitfall. SSO setup. The testers set their own machine to this subnet mask 24. Get this IP address, expecting to see everything in this network space. Okay. So the error, the tester could only reach device in subnet B and not in subnet A, like the client workstation at this IP address 200, but could not reach the domain controller at this IP address at dot 10 in subnet A. Okay, and he had this false conclusion that the domain control as offline, as it was not reachable or offline. Okay, so the reality, the domain was online, but the network was segmented. The tested connection path possibly to their own misconfiguration or a firewall rule on the access point only allowed them to see the second half on the subnet space. Okay, this is interesting. This is very important. It is a real world configuration that you should be aware of. Okay, we're gonna add this to the dictionary. Okay, key takeaways for testing. So here we have never assume a network uses a standard 24 subnet mask. Always confirm that The subnet mask on the target network segments before concluding that the device is offline or unreachable. Okay, there is no need for this. Maybe I'm just gonna leave this one. Never assume. This is the key takeaway. Like, never assume that every network has this usual 24 subnet mask that we have in our networks. Could close this and complete the guide. So let's look at the following high level diagram of how work from how setup may work. Okay, so we're gonna save this image. I call it intro. Then I'm gonna paste this image over here. Gonna upload the file, intro, then open. There we have it. So we have the ISP. Then from the ISP we have a connection to the router. This is our home network. We have our PC, laptop, and smartphone. And that's all. The ICP also provides the internet to our devices. For example, I'm from my PC, going to the AC, to the router, to the ASP, to the internet, to the DNS server, and then to the hack the box or Notion or whatever, right? And then there is a company that using the same ISP that I use, and they have a switch. Other, I do have a switch as well. So yeah, they have an IP phone. I do have this one as well. They do have a web server. I don't have that one. They have a printer. I don't have that one. They have client host, etc. Okay, this is a network on a company. I don't know who. So the entire internet is based on many subdivided networks. Okay, as shown in the example in Mark as home network and company network. We can imagine networking as the delivery of mail or packages sent by one computer and received by the other. Okay, suppose we imagine as a scenario that we want to visit a company's website from our home network. In that case, we exchange data with the company's website located at their company network. As with sending mail or packets, we know the address where the packets should go, the website address or only from source locator URL, okay, which we enter into our browser. It's also known as fully qualified domain name. Okay, so the difference between URL and FQDN is that an FQDN, like this one, like the part.u, only specifies the address. So this is actually the host name. We do call it the host name or the domain name. So fully qualified, we could just delete this one, use this one, domain name. So this domain name only specifies the address of the building, and in URL also specifies the floor, office, mailbox. This one is more detailed. Okay? And the corresponding employee for whom the package is intended. This is very interesting. So let's ask AI to make a note out of this. Okay. All of this is very, very useful actually. Okay, so we're just gonna go and use our older prompt over here. So I want to make like this, copy it, paste it, copy this one, and then send it to AI. Then we're gonna have a prompt. Okay, so we are at network segmentation, subnet mask trap. Okay, so we have here the core concept, subnet mask define, scope. Okay. So that's pretty older that we have read before. So network addressing and communication analogy. So the net explains the high-level concept of how data moves across the network using the analogy of postal delivery system and clarifies the relationship between URLs and domain names. So network segmentation, the big picture. The entire internet is not one single network. It is composed of countless interconnected subdivided networks. Analogy, think of the internet as a map with many different cities, office, buildings, and houses. Home network, your local network like one city. Company network, the remote network you are trying to reach like another city or in business. And there's data transfer networking. It's like sending mail packages between these separate locations. Okay, this was interesting. This is a very cute definition. So imagine like the network is like sending packages in the mail. So we're gonna have here heading 3. I call this definition. Then we're gonna paste this. Okay, I'm gonna delete this. Okay. And delete this as well. And there we go. And delete this one as well. So the big picture, the entire internet. So we just have read this there. Okay, beautiful. Here we have the role of addressing. So when sending data packets from your home network to a server on the company network, you must know the destination address. So if you want to send data packets from your home network to the company network that we have just seen over here, from here to here, you must know the destination address. So you must know the domain name, like this one, hackthebox.com, or maybe the URL, the whole URL, like this one. Okay. Interesting. So you must know the destination address. So the network needs a precise address to route the packet correctly across all the intervening networks. Then you have here the domain name, URL. Okay, so both this and this are resource or network, but they specify different levels of detail. Okay, so the domain name. So yeah, all that. I don't know, but why does he write too much, dog? Like I just could, okay, just copy this one. And this one is way better than this, actually. This one's way more complicated. This was way more simpler. Okay. Beautiful. I'm gonna take this heading, paste it over here. Okay, interesting. See, we're gonna learn about the difference between the domain name and the URL. Let's add this to the dictionary. Okay, great. Okay, so we'll discuss these exact representations and definitions more clearly and precisely in other sections. So the fact is that we now know the address but not the exact geographical locations of the address. In this situation, the post office can determine the exact location, which then forwards the packets to the desired location. Therefore, our post office forwards our packets to the main post office representing our internet service provider. Interesting. So if we don't know the exact location of that URL or domain name, but the ISP takes care of that. Okay. Okay, interesting. Make a note or notion of this. Then I'm gonna ask AI to do the hard work for us. And it's gonna give us a prompt. There we go. So the role of the ISP network routing. This was pretty nice heading that we might use. Okay. There is no need of this one. Beautiful. Then I'm gonna go and hit enter. Let's see more. Okay. So the address we don't know. So from our home, so from on our home, we do not know. So just get this back. Yeah. Okay, it's a little bit difficult. So we don't know the exact locations of that address when sending a package per mail. Okay. And the same thing goes for packages in the internet. So the ISP therefore package. Okay, okay, so I'm gonna go here. Okay, so solution to post office analogy. So I get it. The post office. So the post office takes care of the mail and specifies the location, the exact location, the exact destination, exact location of the exact location. Okay, just location is enough. Okay, the SP plays a similar role. Let's correct this one very quick. Similar role as to the post office from our home network. We send packages. Okay, and we specify a domain name or URL as the location, as the destination for our sent packages, but as from our network, we do not know exactly. We don't know. We don't know the exact location. Therefore, the ISP takes care of that. Okay, interesting. So actually, what I do know is to actually understand more, to grasp and to digest the information rather than passively reading, right? So our post office is our router, which we utilize to connect to the internet and networking. Okay, interesting. Mm-hmm. So as soon we send our packets to our post office router, okay, as to the post office, which is the router, I'm just gonna add that. Okay. So as soon as we send our packets through our post office router, the packet is forwarded to the main post office ISP. This main post office looks in the address register, phone book, domain name service. Where this address is located and returns the corresponding geographical coordinations IP address. Okay, interesting. Now that we know the address exact location, our packet is sent directly there by direct flight via our main post office. Okay, so our package goes through the router, hence through the ISP, and then the ISP looks for looks in the address register or phone book, which is as well domain say, which is the DNS server, you know. And after it takes a look at this DNS server in our case, then it outputs, then it returns outputs returns the matching IP address IP address, which is the exact location of that domain name or URL. So that's why if you don't have a DNS server set up in your network, even if you typed google.com or anything, it won't show up. You're gonna need an IP address. Okay, great. So now that we know the address's exact location, our packet is sent directly there by direct flight via our main post office. So after the web server has received our packet with a request of their website looks like, the web server sends us back the packet with the data with the presentation of the website via the post office of the company network to the specified return address or IP address. Okay, beautiful. So here we have extra points. And that diagram, I would hope the company network shown consists of 5 separate networks. Okay, the web server should be in TMZ, demilitarized zone, because clients on the internet can initiate communications with that website, making it more likely to become compromised. Placing a separate network allows administrators to put network protections between the web server and other devices. This is very, very, very important. It says that the web server that we might have in our company should be in this zone, DMZ, demilitarized zone. And this zone is features by okay, let's read so that we understand. So why do we place the web server in this zone? Because clients on the internet can initiate communications with the website, and because strangers could send us mails to that web server and could manipulate it, so which makes it very sensitive. Okay, and placing it in a different network layer would make us the possibility to set up protections on that web server, so that between that web server and other devices on the same network. Okay, so we put the web server on a contaminated with network so that it doesn't touch other devices, something like that. So workstations should be on their own network. Okay, so workstations that are in the company should be in a separate network, and the website on another network, DMZ. Okay, and it is a perfect world. Each workstation should have a host-based firewall rule preventing it from talking to other workstations. If workstation is on the same network as a server, networking attacks like spoofing or man in the middle becomes much more of an issue. It said if a workstation is the same network as a server, okay, okay, interesting. The spoofing is gonna be an issue in that network. So the switch in router should be on an administration network. This prevents workstations from spoofing in on any communication between these devices. I have often performed a penetration test and saw OSPF open shortest path first advertisements. Since the router did not have a trusted network, anyone on the internal network could have sent malicious advertisements and performed a man-in-the-middle attack against any network. Interesting. So here, IP phones should be on their own network. Okay. Security-wise, this is to prevent computers from being able to eavesdrop on communication. In addition to security, phones are unique in the sense that latency lag is significant. Placing them on their own network can allow network administrators to prioritize their traffic to prevent high latency more easily. You have here printers should be on their own network. This may sound weird, but it is the next to impossible to secure a printer due to how Windows works. Ah, interesting. If a printer tells a computer authentication is required during a print job, that computer will attempt an NTLMv2 authentication, which can lead to passwords being stolen. Additionally, these devices are great for persistence and in general have tons of sensitive information sent to them. Okay. So printers in Windows are a no-go. To actually prevent that is to putting them in their own network in a DMS zone. Here we have a fun story. During COVID, I was tasked to perform a physical penetration test across state lines, and my state was under a stay-at-home order. Okay, the company I was testing had minimal staff in the office. I decided to purchase an expensive printer and exploit it to put a reverse shell in it, so when it's connected to the network, it will send me a shell remote access. Then I ship the printer to the company and send a phishing email thanking the staff for coming in. Explain that the printer should allow them to print or scan things more quickly if they want to bring more stuff home. Okay, for a few days, the printer was hooked up almost instantly, and the domain administrator computer was scanned enough to send the printer his credentials. Oh my god. If the client had designed a secure network, this attack probably would not have been possible for many reasons. So be aware before buying any printer, because that would be vulnerable. Printers should not have been able to talk to the internet. The workstation should not have been able to communicate to the printer over port 445. Okay, printer should not be able to initiate connections to workstations. In some cases, printer scanner accommodations should be able to communicate to a mail server to email scanned documents. Okay. Okay, it's an interesting story. So mark as complete. And that's enough actually. Then we're gonna learn about WAN and W1 VPN. It's interesting. And then here we have our write-up and the introduction to networking. Yeah. So we're gonna read this after another stream in this day. I'm gonna take a long time break, 2 hours, 3 hours. Then we're gonna make another stream, and then we're gonna complete this. Okay. So that was it for this stream.